mentioned, it is the buzzword of today, but we wanted to give it a reality check. We're a player company, so we see a lot of things on the client side, and that's what we're going to talk about today. So first, who are we? I'm the guy on the left, not one of the kids. So I'm Arnaud, I'm a sales director at THEO, and in my personal time, I like to explore the world and basically hike all over the place.
Yeah, hi, my name is Chris. I'm a senior solution architect at THEOplayer. I'm very much concerned with the low latency stuff that we do. In my spare time, most of my time goes into be a taxi driver in the weekend for all the bunch of the kids that you see there. So there's not really much other time left than that than being just an extra way to commute the kids. So Arnaud, take it away.
So, low latency, what is it needed for? So today, obviously, we have a pretty robust streaming infrastructure with protocols like HLS and Dash that are able to basically provide you with a way to get your content in a scalable way to millions of people. But the trade-off there is still today for that scalability is the latency. So typically what we see from customers, I was at a cable operator last week in Europe who basically said, yeah, we do about 50 seconds latency. Which you can imagine, if you want to do live, does have its restrictions. If we're talking actually about live itself, it can be important to distinguish when it is important. For example, if I watch the news live, I don't think latency matters that much. But personally, I'm a sports fan as well. So we recently had the World Cup, actually last summer, soccer. And as some of you might have known, Belgium did quite well for a small country as us. But for us, what was really fun is actually going to the bars and central squares and just really enjoying that. However, one of the experiences that pretty much ruined everything is the sense that you hear a goal, you hear another bar cheering 20 seconds before you actually see the goal happen, which you can imagine in the live situation isn't great. If you look at it a little bit further from the business side, actually that means that it has an impact on monetization. There's even the live situation of game shows where you want interactivity. That's where actually the latency really matters. And today we have technologies like Continuum that basically allow you to go under 3 seconds, which we're going to talk about a little bit.
We're going to ask you to just hold on just a second while we fix a mic issue. We're getting some audio pops.
Test, 1, 2, 1, 2. Test, 1, 2.
We got it in.
Okay.
Good?
Are we good now? Okay. All right, I think it's all coming through. Sorry for the interruption.
All right. Can everybody hear me? Perfect. Okay, so I was talking about the solutions you have today for low latency. So let's have a look at the protocols. So if we talk protocols historically, RTMP, which was actually able to provide pretty low latency. Does it still work? No. No? You want me to speak up? We can hear you. Okay, here we go. Okay. You give me the mic. It's my first talk. It's amazing technology. Yeah? Okay. Where was I? You're a rock star. Thank you. I appreciate that. So, as I was mentioning, RTMP, which was allowed, which gave you low latency, pretty much not a solution today due to Flash. If we look at HLS and Dash, again, brings the scalability, but does have that impact on latency. WebSockets and WebRTC, while they do provide very low latency, the issue there, again, is scalability. So you are actually able to scale with those two, but at an enormous cost, which is actually where Continuum comes in, which brings back that latency and allows for scalability as well. So, Chris, up to you to talk about the trade-offs.
Oh, okay. Everybody can hear me? That's fine. So first off, I just want to add a personal note of why I think this chunked CMAT thing is a big deal, right? So Arnaud mentioned the scalability and offering scalability at an affordable price. But what I think is also very important, and we don't mention that very often, is that chunked TMF is actually a fairly straightforward evolution of the existing HLS and Dash streaming infrastructure and the way that we do it. What does that mean? That means that you can leverage your existing knowledge, experience, your existing infrastructure tools, or at least a part of it, and your existing integrations that you have there. What do I mean with integrations? You're going to want to do TRM. You maybe want to do analytics. You maybe want to do advertising. You want to know what your customers are doing, how you're going to make money off of that. All the existing tools that you have today in your OTT streaming platform, they are still going to work on this. And I think that's a very important point. If we're building out a new streaming service focused on low latency, well, you got the choice of all these partners already in the industry, a choice which is going to give you very experienced tools and at an affordable cost. So that's why I think it's very important. Now, you might have seen many different numbers out there. Chunked CMAP is able to do 3-second latency, 5-second latency, 8-second latency. Well, the answer there is it's a bit of a trade-off, right? So it's mostly about you making choices. Where do you want to put that latency, and what do you have to give in return to get that latency? So for the trade-offs I'll talk about, the first one is you want to have a very low latency. You're probably going to spend less time encoding, and your visual quality is going to suffer. So one of the partners we did a lot of tests with actually just wanted to get on par with broadcast. They used the same broadcast quality settings like you get on a regular television, and they were able to almost achieve that same latency. Now you can easily bring that latency, which is, by the way, at 6-7 seconds, right? You can easily bring that down 3 or 4 seconds, but your encoding time that you're going to spend there is going to be much shorter, and your visual quality or your bandwidth is going to suffer. But it's a choice that you have. You want to deploy a regular broadcast quality settings encoder or a low latency encoder. Second trade-off, that's your buffer size. And with buffer size, we mean the amount of time that is kept in the client device buffer. Why do we need that time? It's to shield us from network interruptions. So the more buffer we have, the better shielded we are against unexpected hiccups in the network and prevent us from buffer stalls. But a bigger client buffer obviously means that you're going to have a bigger delay on the latency, right? Now, a good experience that we have bringing this chunked CMAP to production is that with chunked CMAP, your buffer management is going to be much stabler. So typically, it used to jump up and down by the segment size. Now it only varies by the chunk size. Those chunk sizes being anywhere from 1 frame to a few hundred milliseconds. You get a very stable buffering. But again, this is your choice. You have to decide how much buffer you're going to put in there, and that's maybe going to depend on the network conditions that you're going to deploy on. Are you on a managed network, such as a telco operator? Well, you can have a very small buffer. Regular OTT on normal networks or even LTE networks, you're going to have to add at least a few seconds of buffering there. But again, it's a trade-off. Now, another type of latency that we talk about, and this does not concern end-to-end latency that much, but it's what we call join latency, or sometimes referred to as zapping time, which you can compare to just zapping on linear television channels. What does that mean, this join latency? Well, on average, take for instance that we have a stream, even if it's chunked, our segment size is, for instance, 6 seconds. A client can join anywhere in those 6 seconds, right? He can join straight at the beginning or straight at the end of that 6-second interval. On average, he's going to be at a 3-second interval, right? So your choice has to be there. Do I start playing from the beginning of the active segments, which already puts you at 3 seconds latency additionally, or do I wait for the next segment to appear, and do I first show a 3-second black screen? So that's a choice you're going to have to make. Or you're going to design specific algorithms to cope with that mechanism, such as doing fast decode, but you're going to have different devices, so that's not very evident. Speed up play and some other advanced audio-video trickery. But again, you're going to choose a specific segment size, and this is going to impact your join latency. Chunk size does not matter there. Why is that? Well, even although we have very small chunks, we still only are guaranteed that we have a keyframe at the beginning of a segment. No matter how many chunks you put out there, a client can only play at the beginning of a segment. Even though you put a lot of iframes in those chunks, the player cannot know they're there. So they can only start playing from the beginning of a segment. So that's the join latency. A little bit attached to that is the switch latency. I won't talk too much about it. It's actually, what does that mean? That means whenever you're doing an ABR algorithm and your player detects that, well, I have the capacity to switch to a higher quality, you're going to need at least a few or at least one segment in your buffer, because it might just be that your player starts downloading but doesn't have enough time to download a higher quality and will have to revert back to the actual quality at that time. So you're probably going to need at least a segment available always in the buffer, and for sure your segment size is going to matter there as well. So Arnaud.
So what Chris talked about was, first of all, these trade-offs, which obviously will always have an impact when you go for low latency. But us being a player company, we've actually seen some things on the client side as well that have an impact when you actually deal with low latency. So one being bandwidth measurement, timing and synchronization being linked as well. You will work with different devices. Your clients will use different devices, so you need to think about that. And then our good friends from Apple with iOS, there's always some tricks you need to think about.
Yeah, so about these challenges, right? So these challenges are challenges that you're facing when you're developing your own low latency player. So these are challenges that we as a player company encountered. We just want to tell you a bit about the challenges that you would encounter if you decide to build your own player there. So bandwidth measurement, that's a very important one, because chunked transfer means that your effective throughput is lower. Why is that? If we're downloading an active segment, again, that 6-second segments which we were on, I'm downloading that. That can only be produced at real time. It can't be produced faster because it's the live moment, right? So you can only download it at that speed. So previously, when we did some kind of bandwidth estimation, there was an easy way to figure out just by downloading the segment, looking at the segment size, figuring out how long it took, and make the division. That gave us a fairly easy estimate of the bandwidth that we had available, and we use that effectively in our ABR algorithm. So when do we decide to switch to a higher or a lower quality? What are the network conditions? If you cannot rely on an effective measurement of the throughput of your chunks, then you have to gonna figure out another way of dealing with this. Another challenge is timing. And what is timing? By timing, I mean the clock accuracy on your client devices. Very often when we are developing a player, the player will run on a device in which device we have no control whatsoever on the accuracy of the local clock. Now, many devices today will have by default some good system settings to synchronize with a time server out there, but we do see that in many cases that's not enough for playing very close to the live point. On average, iOS and Android devices, fairly good default system settings. Windows machines, they're a bit off from time to time. So this thing becomes very important when we have a mode in AmpEck-, which is called number mode. I don't know if you're aware about the different modes in which we can have a manifest in AmpEck-, but number mode actually means that the client can predict in an algorithmic fashion what the name of the next segment is going to be. And paradoxically, to figure out that number, it needs the time. So the other mode is a time mode, where the server will just give us a list of elements that are available, and we just have to download that. With number mode, we have to do some calculation from which we need a very good local client time. Basically, what does that mean? Start of the stream, the duration of the stream, average segment, divide that, you get a number, that's the name of your segment. If your clock is off on your client device, you're going to be off at your live edge. So the Dash IOP 4.2 actually introduced a way of signaling to your client a standards way of inserting some timing information. And it did that through the UTC timing element. So that's an element that you can push into your manifest. And there are 6 different modes of doing that. Various modes involve NTP, which is kind of a drag, certainly if you're only doing a web browser. One very relevant one, and one that we see used most often, is the ISO 2014. That means that you actually just have a server out there that will give you a JavaScript formatted date timestamp to which you can synchronize. So for these timing issues, you need to have your client to be aware that there is a timing service out there, and you're going to need an accurate time server out there. That ties nicely into the next slide, which is synchronization. So synchronization in itself doesn't really have to do that much with low latency, but it's actually a use case or a request that we come across rather surprisingly often. Synchronization, what does that mean? I have different devices. They all suffer from a certain client or buffering or join latency, which will be different on different devices. And many use cases, people don't want one device to be 1 second ahead or 2 seconds ahead of someone else, even more so that they prefer to have a synchronization on the client devices rather than having those very low latency numbers. So synchronization is very important. You want to be able to do it cross-device and sometimes even cross-protocols. You want other streaming protocols also to be aware and to be in the loop of this and to have a nice synchronization pattern across these devices. So what do you need for that? Obviously, a very good, accurate client clock, which we saw in the first slide. Secondly, a way to read out timing information in these streams. Now, how do you get timing information? You could insert it into the stream, but what we see used most often is actually base it off the metadata available in the manifest, which works fairly good. And then finally, you're going to have have a way of your different players and your different platforms, a way of enforcing that latency. So you set up front, I want, for instance here, we have a demo that said we want 5 seconds latency, and then you want your player to actively verify that each and every interval that you still are within that latency. If you're without that, you're going to want to take preventive measures, maybe just speed up play, slow down play, maybe seek or jump, or maybe in an application just block operations for a user, right? So synchronization is a big thing, but probably the biggest challenge out there for chunked CMAF is that we do not have iOS support. We have CMAF support on iOS, so the regular fragmented MP4 segments, even if they're encoded in a chunked fashion, you can play them back on your iOS device, but there's in HLS no way to signal that there are chunks in your stream. So yes, segments, but chunks, no. The HLS manifest does not provide a way for you to do that. This is actually a technical limitation around which we could work, but Apple enforces an App Store policy that says that you have to do HLS for media which is longer than 15 minutes. So we're a bit at the mercy of Apple if your content is longer than 15 minutes, and if you're on a mobile network, you have to do HLS. So no MPEG Dash or other trickery that you can do at this point. So if you can't do chunked CMAF on iOS, what are your options there? Don't do iOS, right? So maybe a bit off topic, but it's a very valid use case for some people out there. For instance, telecom operators, they cater to their own set-top box, which is maybe a Linux box, a proprietary thing, an Android TV device. They don't need to do iOS, so they don't care. So they can just use chunked CMAF to do their low latency streams. We, for instance, have a customer who builds out a streaming SVOD, AVOD service for football matches, and they ship their own set-top box device with that. So they don't need to do that.
I think you've offended all the Apple users, though.
I'm sorry? So what are your other options? Do regular HLS CMAF, as we said. So it's the same segments, the fragmented MP4 segments that you encode for your chunked CMAF on MPEG Dash. It's available on iOS 10 Plus, but you don't get low latency support. If you use Apple suggested 6-second segments, you're looking at an 18 to 24 second latency, which is obviously not a low latency solution, right? The other option to go, and here we're lowering the number, is to do HLS with reduced chunk size. So you can do HLS CMAF, fragmented MP4, or a transport stream if you want to cover those older devices. And what we've seen many people do is they tend to go with 2-second segments. Your HLS fragments are going to be 2 seconds. It's a very realistic option, and this is going to put you in a 10 to 12 second ballpark. If you're more adventurous, or if you really, really want to squeeze out the maximum potential of HLS today, you could even go with 1-second segments, but be aware, you're going to have a gap every second, so this will severely or drastically impact the size or the quality of your stream. This will put you actually in a 6 to 8 second range, which is quite on par with broadband, right? With broadcast, I'm sorry. So one thing to be wary though, if you're going to use 1-second segments, your manifest can grow rather large. So if you're going to do an event type playlist on an event of 2 hours, you're going to look at 7,200 entries in your manifest, which may be a lot, right? Final option, go with any of the LHLS varieties out there. So LHLS is specific kind of chunking support for transport stream HLS. But you're really going to have a lack of ecosystem support. So you're probably going to need to do some kind of open source encoder there. There are not too many professional encoding services that will effectively support you in publishing an LHLS stream. And basically, you're going to be at the mercy of Apple. If they're going to pull the plug on this thing, or if they're going to close down their players, you're going to have that investment for nothing. Also, yeah, that was a point that I'm going to make later. But yeah. So what are our suggestions today? If you really need that support on iOS and you want to go low latency, is do chunked CMAF with a 6-second or a 2-second segment on the compatible devices, web browsers, Android devices. For iOS, do a HLS, either CMAF HLS or transport stream with a reduced chunk size of 1 or 2 seconds. And if your use case requires it, do synchronization. So you don't want your chunk CMAF to be at 2 seconds and your HLS at 10 seconds. Well, enforce your chunk CMAF to be at 10 seconds as well.
So to wrap up, what we wanted to show today is actually when you do low latency, we want you guys to think about other things than just reaching that latency, like the trade-offs that Chris mentioned when it comes to bandwidth, when it comes to quality, but also that you have to think about the devices you want to reach, because there are certain challenges when it comes to synchronization, when it comes to iOS specifically, but luckily there are solutions out there today. Last but not least, we wanted to show you something extra. So some of you might have been at NAB and seen that actually we've launched a new product at THEO, which is actually going past chunked CMAF. So what we look to do is actually what will be the next thing after chunked CMAF. And we basically came out with our own protocol, which we call HESP, High Efficiency Streaming Protocol, which is over HTTP, is able to deliver sub-3 second latency, also reduce bandwidth, and get to a joint latency of around 90 milliseconds as well. So today, this is still in our R&D labs, and we are actually looking for packager and encoding vendors to bring this to the market with us. So if you do have any questions, please ask now, or you can meet us at our booth back in the hall. Thank you for your time.